Okay, let's get back to work here. All right. There's a quick section in here before we get on to the next topic of percents and proportions. And this topic is factoring. It's just a quick section on it. We will do more factoring later. All of you have factored before, or at some point in your life, if you've done some math, you've had to factor. When it comes to factoring, there's like a process that you follow. And the first step to factoring anything is this step right here. And that's all this is about, is making sure everyone remembers the first step to trying to factor something, and that's called the greatest common factor. So as a reminder, what factoring is like, let's say you have this expression. Let's say I gave you that right there and asked you to multiply it together. Then what you do is you take this 3, there's multiplication there, you distribute that through, you get 3x minus 6, right? Okay, that's not what factoring is. What factoring is starting here and going back to this. So you're kind of reversing the operation. So if I was going to go here back to here, what I'd have to do is I would have to identify this thing called the greatest common factor. So what you're doing is you're looking at each of the terms, and in this case I have 2 terms, and you start by saying, is there a number that goes into both 3 and 6? What number divides 3 and divides 6? 3, right? 3 goes into 3 one time, and 3 goes into 6 twice. So I know I have a common factor of 3. And then I start looking at the variables. Here I have an x, here I don't have an x, right? So they have nothing in common in terms of the x. So the only thing that these terms have in common is a 3, right? So what we would do is we would say, okay, we have a common factor of 3. I'd write 3 down, then I'd put a parentheses here, and I would leave myself enough room in this parentheses for 2 things. Because I have I started with 2 things, I leave myself space for 2 things. And what I have to do is kind of like reverse engineer this, figure out what I put here and here to get back these 2 things. So what would I have to multiply 3 by in order to get 3x? Just an x. And then what would I have to multiply 3 by to get negative 6? Negative 2, so I put minus 2 there, and that's how we get back. So that's going from here back to here is factoring using greatest common factor. So that's what we're going to do on these problems. So how about this first one? How many terms do you have here? 2. All right, let's look at the first one and the second one and see, is there a number that is common to both, that goes into both 6 and 6? Well, 6, right? Does 2 go into both? Yes, but we're looking for what we call the greatest common factor, which means you want to find the largest number that goes into both. So 6, how about y's? Do they both have some y's in them? No, so the only thing that I have in common is a 6. So I put a 6 here, set of parentheses, enough room for 2 terms, right? Something here and something here. And then I just ask myself the question, what do I have to multiply 6 by in order to get 6y squared? So y squared. And then very important, what would I have to multiply 6 by to get 6? Plus 1. I need to have plus 1. See, some students, what they do is they don't put the 1 here at all, because they say to get 6, well, I already have 6. So they don't put anything. And they just put 6y squared. You have to have the plus 1 in order to get the 2 terms out. The distribution has to occur to get the 2 terms out. All right? All right, look, what about this one? 2 terms again? So I mean, I could, if I want, starting this problem out, I could start by putting the parentheses enough for 2 terms and then just trying to figure out what my greatest common factor is out here. So how about numbers? Do I have a greatest number in both of these? 1 is the only thing that goes into both of these, right? There's a 1 out here. 1 is the only thing that's common to both. So I could technically put a 1 out here, but we don't need to, all right? So I look at the numbers. There's no common number that I can pull out other than 1. So then I move on to the x's. I have an x here. Do I have an x here? No, so I can't pull an x out because they don't both have an x. How about y? Yes? Y squared. They both have y squared. So I can actually put a y squared out here. And then I just play this game again where I try and get back the two pieces here. So what would I have to multiply this by to get back this? What am I missing? That's another question you could ask yourself. All I'm missing is the x, right? Y squared times x would give me the xy squared. What would I have to multiply y squared by to get this? Negative 3. The good thing about factoring is you can always check, because you can just distribute, and you better get back this, right? So this is the answer right here. How about this one? Enough space for two terms. Do they have a common number? 3, so I can have a 3 on the outside. How about x? Yeah. So I have x squared here, right? And I have just a single x here. The greatest common factor is what they both have in common. And all they both have is a single x. One of them has 2, but the other one only has 1. So you're kind of going to pull out like the minimum number of x's that appear. So I'm going to have a single x out here. And now, what are the two things inside that you need? So this, to get back that, you need an x, right? And then this times what gives you this? Plus 2. I hear people responding, so I'm assuming that this is okay. All right, the next one looks really bad. I'm going to put a parenthesis. I'm going to give myself enough space for 3 things. And that's because I'm starting with 3, right? All right, what about a number? 4. 4? So I need something that goes into 16, 28, and 48. So 4, is 4 the biggest one? Yeah, 8's too big, right? 8 goes into here, but 8 doesn't go into that. 8 goes into that? Yes, but doesn't go into here. So 8's too big. What about 2? 2 goes in all of them, right? But it's not the biggest one. So we're looking for the greatest common factor. That would be 4. How about x's? Nope, I have x squared, x, that's good. I could pull one x out, except this doesn't have an x. So I can't pull an x out. How about y's? Y squared only, right? And that's because this has y squared, that has y squared, that has y to the 5th. That's even more than I need, right? But they're common. What's in common is a y squared. So what do I need to multiply this by to get back this thing right here? I need a 4 to make the 16. I need an x squared because I have no x's here. And the y squared I already have. So just 4x squared. All right, what do I multiply 4 by to get back negative 28? Negative 7. I also need an x because I have one here, I don't have one here, and then y squared is already taken care of. Last one, plus 12, and then y to the 3rd power, y cubed. These things that we've been pulling out right here, those are called the greatest common factor, right? So the greatest common factor of this is 6. The greatest common factor of this was y squared, 4y squared, 3x. All right, the last one. What number, give myself enough space for 3 terms here. What number goes in all those? Biggest number? I think 5, right? 5. Okay, how many x's can be pulled out? 2 factors of x, right? So x squared. And then how many factors of y can be pulled out? 3 factors, so y cubed. And then you just play that little game again. So what's that first term need to be? I need a 5 to make the 25. I need an x so I can go from x squared to x cubed. And I need a y to go from y cubed to y to the 4th. Y'all good with this? What's my next term? Minus 13. Okay, so that's 5 times negative 13 is negative 65. I need an x squared. I have it, right? I need a y to the 5th. I have y cubed, so I'm going to have to include y squared there. And then finally, I need a minus because it's negative. What do we got? 16? 16. And then x squared only. Yeah. Okay, that's it. Yes?
So this is like in the future, but on tests, are we going to be given formulas?
Question is whether or not you'll be given formulas on a test. What's going on up there? Hold on a second. It's been recording, but it was stuck on a different screen. Formulas on a test. We're going to have to see. There will be an option for formulas. What I've done in the past is like one of two things. Either I say, you can have a formula sheet that you make yourself, okay? Like a cheat sheet almost, but it can only have like formulas and steps and procedures. You can't have a bunch of examples written down on it, okay? I've either said that if you use one, then, no big deal, you use it, right? If you choose not to use one, then you get an automatic 5-point bonus or 10-point bonus on the test. Or the other thing I've also done is said, if you don't use one, fine, everything's good. If you use one, then there's a 5 or 10-point deduction on the test. So it's like if you're going to use a formula sheet, cheat sheet, then the highest grade you could get would be like a 90. Does that make sense? So I usually leave it as an option for the student. I haven't figured out which one of those ways it's going to be yet. Okay?
Thank you.
Does that help? All right. But I will offer you at least the opportunity for it. You probably prefer the first option there? Yes, yeah. There's different philosophies about cheat sheets in the math department here. And there's a strong group that believes that cheat sheets should not be allowed. And I guess my philosophy is that, in the real world, right, no matter what it is that you wind up doing with your life, you're never really trapped in a room with no resources, right? I mean, that never really happens. And so it's more about, like, when you create a cheat sheet, you're identifying your weaknesses, you're trying to figure out what you need to know, and that in itself, I think, is beneficial. So I see value in having a student create their own, but, like I said, it's frowned upon by some. All right, we are going to move on to, so there's the homework for that section. We're going to move to percents. So before I begin percents, let's just make sure we all understand what a percent means. So if you write something like 3%, this means 3 out of 100. 3 out of 100. Another way of looking at that is by writing it as a fraction, 3 over 100. And if you get on your calculator and you take 3 and divide it by 100 on your calculator, you're going to get an answer, 0.03. So this form right here is the decimal form, right? And then this, of course, is the percent form. So what you need to know as we move through these problems is that if somebody gives you a percentage, that it means, this fraction. But more importantly, if you wanted to convert that percentage to a decimal, essentially what you're doing is you're recognizing that next to this 3 is a decimal point. And to go from a percentage to a decimal, you're going to move this over 2 places, which creates your 0. So imagine the decimal point was here. If you move it 2 places and now it lives there, now you have a 0.03. So So that's just kind of like this rule of thumb everyone needs to be comfortable with. To go from percentage to decimal, you move the decimal point 2 places to the left. To go from decimal to percent, you move the decimal point 2 places to the right. Yes?
Yes.
So when somebody writes 100%, right? 100% of you love math, right? What does that mean? That means 100 out of 100, right? Written as a fraction, it's what, 100 over 100? And if you get on your calculator and do that, or if you just look at it, that's 1, isn't it? So 100% is the same as, in a decimal form, is the number 1, and then you could put 0.0, but the number 1 is 100%. Now, I have a question for you. Let's see how many of us there are in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17, 18, 19, 20, 1, 22, 23. There's 24 of us in here right now. I think someone left. We'll count them, okay? We'll actually count them. All right, we have 25. How many of you have an Apple iPhone or something like that, Apple product? Let's do it the other way. How many of you don't have Apple and are using Android or something like that? Okay, so 1, 2, 3, 4, 5, 6, 7. So we have 7 out of 25 are using Android. And that means, oh wait, hold on. iPhone or Android, what do you have? iPhone. Okay, so still 7 out of 25. And then that means what, 18 out of the 25 were iPhone? Yes? All right, now as a percentage, what is the iPhones versus Android? So how would I do this as a percentage? Okay, so yeah, I would just take, I tried to do this in a class a couple of semesters ago, and it was the entire class was iPhone. I was the only Android. I was the only one. Okay, so let's see. We have, if you do this as a fraction, 7 out of 25, and then somebody do that on the calculator for me and give me, what is it? 0.28? And that means if we convert that to a percentage, that's 28%. It's actually pretty high in my experience. And then, of course, this would have to be 72, but 0.72, and then that would be 72%. Here's why I'm saying this. What's important about percentages is this. If I were to walk in here and I were to say, hey, look, 72% of my students use iPhones, I don't mean 72 out of 100 in the sense that there are 100 of you, right? It's a ratio, it's a proportion. So we use percentages as like the standard. It's like if there were 100 students in here, right? If there were, 72 of them would be using iPhones, even though our population may not be 100. But we use the 100 as like the benchmark to compare things. Right? Okay. I was going to say something else. Oh, let's try this real quick experiment. All right, let's see if this happens. January birthdays. Okay, I'm just going to ask you the numerical date. So what day in January? If you're uncomfortable with me asking about birthdays, then you don't have to participate. 11th? 29th? 26th. Okay, we're looking for anyone who shares a birthday in here. All right, so no more Januaries, we're done? February? You're the only one? Okay. What's next? March? March? No March birthdays. Okay, April? Okay, what do you got? 25th? 16th? Okay. May? What do you got? 10? 21st? June? What? June what? You had to think about that. 22nd? 20th? 28th. Okay, so no. Where are we at? July? What do you got? 14th? 21st? 25th? August? 14? 30? No, 3rd? 28th? 11th? I'm 31st, so no. September? What do you got? 5th? 17th? Oh, it's starting to look bad. October? 21st? 20, oh, close. Where are we at? What was that? We're November? December? You're the only one. Okay, well, we still have a chance. Go ahead. 27? Nope. Okay, so what do you think the odds are that one of us shared a birthday? Now, it didn't happen. But what do you think the odds are? There's 25 of us in here. What do you think the odds are that we would have a match? Do you think they're good? You think it's 75? So you think it's like real good?
Yeah.
Really? Okay. Anyone think it's like not good at all? So it turns out, I don't remember the exact number, but it's in a classroom of about 30 students, it's a coin flip. It's about 50-50. Which for a lot of people, they don't think that it would be that good odds. But if you get about 30 people in a room, the odds that two people have the same birthday are about a 50-50 shot. And it seems like it wouldn't be that way, but it is. That's an off-topic, random thing that I'm just giving you, okay? It has very little to do with this, other than the fact that 50-50 means about 50%, so it is a percentage, right? All right, let's proceed. We are going to work on some small word problems here. These are very straightforward in terms of there's no complicated like language in here, like, Robert, shoveled 25 barrels of this. What percentage? There's nothing like that. It's just very straightforward. What percent of 200 is 21? So what we need to do here is recognize key words in these mathematical or in these sentences. When you say what percent, okay, what percent? That is what they're looking for, right? You have to give them the percentage. They're asking what percent. So this is really like X in the problem, all right? X, now when you see the word of in mathematical statements, I alluded to this earlier in this class. What does the word of translate into? Multiplication. Multiplication. So this of right here is going to become multiply. And then 200 is just going to be 200. And then when you see the word is in mathematical equations, is, what do you think? Equals. And then the other side is 21. All right, do you see how that was translated? So what percent is just something we're looking for? Of 200 times 200 equals 21. So let me just rewrite this. This is really saying 200x equals 21. I just switched the order. X times 200 is the same as 200 times x. We talked about that earlier, that multiplication is commutative. And how would you solve that for x? Divide both sides by 200. So if I divide this side by 200, divide this side by 200, then I would get that x is equal to 21 over 200. What I'd like for you to do is on your calculators, go ahead and type it in and see what you get. You get 0.105? Okay, so I'm going to write 0.105. The only reason I put a 0 out front is so that you really are sure that there's a decimal there, all right? 0.105. Now convert that to a percentage. Why do I want to convert that to a percentage? Because in the very beginning it said what percent, right? So we want to convert that decimal to a percent. So we move the decimal which way? To the right 2 places. So this is the same as 10.5%. Now, I always suggest that you come back over here and you kind of plug your answer into the word problem and see if it makes sense. 10.5% of 200 is 21. Does that make sense that that's correct? What would 10% of 200 be? What would be 10% of 200? 20? Okay. So let's move on. Help me out here on this next one. 15% of a number is 19.5. So what should I do if I'm just going to try and translate this into an equation? 15%, just bring it down, or maybe I should change it. Should I leave it, change it? What should I do? Why don't we move it to, change it to a decimal, 0.15. Okay, 0.15. Of means times. So I have times a number. A number. X, right? That's what we're looking for. Is equals, and then 19.5. So we have 0.15x equals 19.5. How would you solve that for x? Divide both sides by 0.15, right? So do that on your calculator. You're going to do this on your calculator. And we should get a pretty big number. 130. Do I need to convert this to a percentage or do anything with this? No, because that's supposed to be just a number, right? And we could check it. Is 15% of 130 19? Well, I feel good about that. I guess it is, right? 15% of 130 is 19.5. Help me out with the next one. What's the equation going to be here? Okay, so we bring the 25 first, right? 25 is means equals. And then 40% is going to be 0.40. And then of means multiplication. And then what means x. And then you divide both sides by 0.4. Let's just get to the next equation. What is this one saying?
What is 35, or x equals?
X is the what, right? What? X is equals 35% is 0.35, and then of is multiplication, so times 200. See, that one, x is already by itself, isn't it? You just have to get on your calculator and do 0.35 times 200. When I do this, I start to go away from these dots. I start to just put this in parentheses, and that way I don't get confused with my decimals and my multiplications. But we good? All right, let's move on to the word problems. Let's look at number 7. And last class we stopped with these groups. Oh, you know what? Let's pass around sign-in sheet because I'm going to forget about that. Sign-in sheet. Are you all ready to vote on that thing? Yes? I'm going to pass that around. I'm going to start it over here. Remember, this is for you to vote whether or not on July 16th or 18th you want to come to class with a substitute, or you want me to provide you with videos that you would watch on your own and be expected to know what, you'd be responsible for that material. So I thought about doing like an individual voting for everyone so you wouldn't see other people's votes. Are y'all okay with you being able to see everyone? Okay. Well, yeah. 16th and 18th. I think it's a Monday and a Wednesday. Right?
Who's the substitute?
I would not have control over who the substitute would be. I would request one, and whoever was able to would do it. Yeah.
Did you see his credentials?
Yeah, unfortunately.
No English teachers, right?
Yeah, it would be an English teacher. It would be an art teacher. All right, here we go. While that's going around, let's look at number 7, because this is where they start to get, well, would you all agree that the problems we just did, there's kind of a systematic approach to them and you can kind of get it down? All All right, here's where things start getting kind of loopy, all right, because we've got word problems again. So let's read this carefully. 30% of all students at Northwest Vista College transfer to UTSA. Oh, God, what did I just do? Whoa. Where are they? There we go. I was trying to bring this up so I have something to write on. All right, can everyone see the problem? 30% of all students at Northwest Vista College transfer to UTSA. Of these transfer students, 12% are going into biology. If there are 15,435 students at Northwest Vista, how many will transfer to UTSA and major in biology? Now, I'm a big fan of pictures when we can do pictures because I think it's helpful. So here are the students at NVC. All right, how many students are at NVC? There's 15,435. All right? The first sentence in the problem says 30% of all the students at NVC transfer to UTSA. So there's this group right in here. 30% are going to transfer to UTSA. Right? Can you tell me how many that is? What did you do there?
I just multiplied that big number by 0.3.
By 0.3. So what we're asking ourselves here is these students here, the MVC students that transfer to UTSA is 30% of 15,435. Do you agree with that? So 30% of this is multiplication. So you're going to be doing 0.30 times, and again, I'm going to do the parentheses instead of a dot. And someone did that on their calculator, and what'd they get?
4,630.
Okay. Is it? Yeah? Oh, is it 0.5? 0.5? Okay. So this is a good illustration of how I was talking about earlier. 72% of the iPhone users, right, in this class doesn't mean we have 72 students in the class. If we say 30% of the students transfer to UTSA, that they're saying on average that's what happens, 30%. You can have a student population where when you take 30% of them, you actually get a decimal, which means you have a partial person, right? I'm not going to use your language because it's 2018 and I pretty much can't say anything, especially on camera. So, but I will say that I think we could argue that we've met people that are perhaps half people, right? Just like mentally, you know. You could argue, I think. You could argue there are partial people. All right, so that's about how many transfer to UTSA. That's not what we're being asked, though, right? Yeah. Because of these transfer students, 12% are going on to biology at UTSA. So now you've got these people that have transferred out, right? You've got these people that are now at UTSA that have come from here. How many are there? 4,630.5, right? And of that group, 12% are going to do biology. Right? So how do we get that number then? Same thing, right? So now what we're going to do is we're going to do 12% of the 4,630.5, which would mean .12, converting that to a decimal, times 4630.5. Anyone got that for me? 555.66. So again, this we have a little bit more than half a person here. And that's it. Approximately 555. So of the 15,435 students that are Northwest Vista, we should expect to see about 555 of them at UTSA as biology majors. Now you could have done this all in one swoop. You could have done 0.12 times 0.3 times that, all of it at one time. But I think this breaks it down better and you can kind of see what's happening. We good? Sure. All right, let's move on. I think that's the same question, isn't it? Oh, hold on, we have to be careful here. It may not be. All right, so it looks like we have a pretty strong majority that are okay not coming to class and doing a video lecture. For anyone who voted for a substitute, I'm not going to call you out or anything. If it really is troubling to you that you're not going to have someone up here, I will find like a way to help you out if you really feel strongly about it. So just talk with me. There's the tutoring lab across the way, and I can have them maybe set up a session where they can sit down with you and go over the topics that I would be going over. All right, but I'm going to leave that in your hands. So I will say officially, I will do something on the syllabus or on the schedule. I'll update the schedule on Canvas that reflects that on the 16th and 18th there will be no class. All right, but I'll put something that has what the expectations are and blah blah blah. All right, so is number 8 the same problem?
Yeah, just minus the amount of students.
It's not the same problem. We have to be careful here. 30% of all students transfer, right? Okay, so that's the same. Of these, 12% are going to major in biology, right? But we're missing how many students were at NVC, right? And the question is, what percentage of the NVC students are going to be majoring in biology at UTSA? What percent, right? What percent? And here it was how many students? We said 555.66 or something, right? This one's asking what percent. So here's the way I guess you can look at this. Almost made it. So let's start off again with a little picture. Here's NVC. And how many students are here? Well, we don't know, right? We're not given that information. So let's just say it's X. That's how many students are there, right? And then how many of those students are going to go to UTSA? 30% are going to go to UTSA? So how much would that be? I mean, how many would that be? Wouldn't it be 0.30 times X? Yes? That's how many are now at UTSA. And then of those, what? 12% are going to go into biology. So how do I get that? Yes, so we're going to take 12% of this number of students, right? So isn't that 12% of 0.30x? See how that works? First we did 30% of the population of Northwest Vista College, which is 0.30 times x. Then we're going to take 12% of that 30%, which means we're going to take 0.12 times that. And now on your calculator, do 0.12 times 0.30. 0.036x. See, we still have the x there. Well, are we there? What does this represent? That's the percentage. Look, if we move this decimal point over 2 places, isn't that 3.6%? So this means 3.6% of the population of Northwest Vista. Because remember, there's multiplication in here, which really means of, right? So what we're saying is 3.6% of X. That's the population at Northwest Vista College. So the answer to the problem is 3.6%. We should expect to see 3.6% of students at Northwest Vista become biology majors at UTSA. Welcome.
I
Yes.
used the answer we got on 7 to get 8. I just took
Oh, yes.
555 and divided it by the population of students, and it gives you the same answer.
Yes, it does, but you're assuming that these two problems are somehow connected to one another. Yeah, I mean, yeah, so I agree. If we assume that the data is the same, we're talking about the same data set, then you could assume that. But let's say number 7 never appeared, right?
Yeah.
If number 7 was never given to you, then to do number 8, you would have to do it this way, right? Which means, like, if I give you a test and I give you a problem like number 8 without anything like number 7, you would have to do it this way. All you're doing really is just multiplying the two percentages together, right? You're doing 0.3 times 0.12, right? That's what you wound up doing. All right, let's see what else we've got. This one looks interesting. Has alcohol in it. In a Gallup poll, 976 adults, 68 said they drink alcohol every day. Seems low. What is the percentage of respondents who said they drink every day? So what are you doing here?
Same with the x's, which is the percent.
You're doing what?
Find out what your x is, and that's the percent.
Okay, so your x is your percent. Well, what's the equation you're setting up? Or are you setting anything up?
68 divided by 976.
So you're doing 68, right? These say they drink, right? Every day. And that's out of how many? Well, let's say of, right? Of 68 people drink of how many people? 976. So that really turns into 68 out of 976 turns into this fraction. And then that fraction on your calculator turns into a decimal, which was what? 0.06? No. Yeah? 0.06. And then that to a percentage is 6%. Six percent of adults in this poll drink alcohol every day. All right, we're going to move on to proportions. Proportions and percentages are connected, but they're a little different. So proportion is something like this. We would say that those two fractions are proportional to one another because they're equivalent, right? Like 1/2 is the same as 5/10. You can write that many different ways, right? You could also say that that's proportional to 7/14. I mean, there's an infinite number of ways, right, that you could do this. all of these fractions are proportional to one another, because if you reduce the fractions, you would get the same answer at the end. All of these fractions would reduce out to be 1/2. So to say two things are proportional means that they are fractionally equivalent to one another. Now, where does this come into play? Something like this. One plain bagel has 320 calories. How many calories are in 2.5 bagels? All right? So you could try and just mess with this on your calculator, or you could use proportions. So I'm going to show you how to do this using proportions. So I'm going to take this first sentence and I'm going to write something down. I'm going to write one bagel over 320 calories. And what I've set up is a proportion that was given to me. For every one bagel, it's 320 calories. If I double this, right, if I put 2 bagels here, this would double, right? If I triple this, this would triple. So I have set up a proportion. Now, you could have set it up this way also. You could have done, I'm going to put cal instead of calories, over one bagel. You are free to have set up the proportion flipped over. You could have said 320 calories per bagel, or one bagel is 320 calories. So proportions don't matter, all right, which way you set them up. But let's look at what we're being asked in the question. How many calories are in 2.5 bagels, right? How many calories are in 2.5 bagels? So I'm looking at these two equivalent proportions, and I'm looking at what I'm trying to find. And here I want to know how many calories, right? So I look at which of these two have calories on top. Because I'm looking for calories, I'm going to use the one that has the calories in the numerator. So I'm going to actually use this one, all right? Do y'all get that? When you're given a proportion in a problem, you have two ways of setting it up. The way you set it up should be dictated by what you're looking for in the question. So I'm going to choose this one, not this one, all right? Y'all got it? Now, using this proportion, I'm going to say that this is equal to, and now I'm going to create a new fraction next to it. And that new fraction is also going to be calories over bagels. And now I'm going to use the information that I'm given. I want to know how many calories are in 2.5 bagels, right? So over here, I want to know the calories, so I'm going to put X here. And on the bottom, I'm going to put 2.5 bagels. Y'all see what I've done there? You sure? If you had chosen to do it this way, well, let me not show you that until after I finish this. All right. I'm going to now try and solve for X. All right? That's what I'm going to try and solve for. So if I want to get X by itself, then what I need to do is get rid of the 2.5 bagels on this side of the equation. And that means I'm going to multiply both sides by 2.5. Understand? So if I multiply the left side by 2.5 bagels, I'm going to put 2.5b, okay? Is that all right for bagels? And multiply this side, I might go off camera here, by 2.5 bagels. Then the bagels will cancel on that side. Because I'm multiplying it, and this is dividing, the bagels will cancel here. Right? The 2.5 and the bagels will cancel. Over here, won't the bagels cancel there? Just the unit bagel will cancel here. And I need to do 2.5, this is like a fraction, over 1. 2.5 times 320. So on your calculator or in your head, whatever. 800 even? 800 even? Okay. So 800 calories is X, right? That's what X is. Now, I realize some of you got that answer a long time ago, all right? But what's more important right now, because the problems will get harder, is that we understand how we can set up a proportion and then use that to answer the questions. Here's why I didn't use this one. Let me show you why I didn't do this one. If I would have done this, I would have calories down here. I would have had bagels on top. I'm trying to find calories, and 2.5 would have been on top. And the problem with setting it up this way is that what you're solving for is down in the denominator, which means you have to get it out of the denominator before you can actually solve for it. So I have to multiply both sides by x, and then that can just be, it's just an extra step, an extra place you can make a mistake. Let's do another example before you get too paranoid about this. Let's do that leaking pipe problem. And then remind me to tell you about an actual proportion problem that I did the other day. Like, I actually used this for something. Now, it wasn't very useful, but remind me, I'll tell you a story after this one, if you want to hear it. All right, what do you think? A leaking pipe can lose 24.7 gallons in a week. Right? That's a proportion, isn't it? And I can set that up one of two ways. I can either say 24.7 G for gallons, is that all right? Per 1 week. I'm going to put, I'll write week, okay. Or I can say 1 week and I'll lose 24.7 gallons. So my choice on that. Now look at the question. How many gallons are lost in 30 days? So I'm looking for gallons, right? So I'm going to use first one or second one? First one, because the gallons is on top. All right, so I'm not going to use this one. So I'm going to write 24.7 gallons over 1 week is proportional to or equal to, and now what am I going to write on the other side? I'm going to have gallons here and weeks here. And X, right? X here. And this is the part. Pardon?
Week to 7 days.
Yeah, so we have a problem here, don't we? Do y'all see it?
Change the week to 7 days and keep it 30 days.
Days and weeks are two different units of measurement. So I cannot put 30 here because that's weeks and that's not, we have 30 days. So I have two options. I either need to convert 30 days into weeks or I need to change this weeks to days. And I think everyone would agree that it's easier to change a week to days. Yes? Okay, so let me do that. Let me change this. Is that tricky? That's a little tricky, right? You have to be careful. Let's change this into days. And we would need to change that to 7, wouldn't we? And now this would be changed to days. This marker's terrible. And this would be 30. That one's not so great either. Make sense? And now, what would I do to get X? Multiply both sides by 30 days. So times 30 days over here, times 30 days over here. The days are gone. This whole thing's gone. Everything's gone there. On the left side, the only computation you have to do is 30 times 24.7. Right? Oh, wait, no. Sorry. I divided by 7. So 30 times 24.7 over 7, this is gallons, equals X. So remember, this 30 over here is really like a 30 over 1. So you go across the top and the bottom. So 1 times 7 is 7. 30 times that is something. So does anyone have that whole thing done? All of it? 105.85, whatever. Okay, good enough. I'm not going to be super particular about your decimals in this class. So if a leaking pipe can lose 24.7 gallons of water in a week, then in 30 days we could lose 105.85 gallons. With this particular leaking pipe, I'm sure you could lose a lot more with depending on the leak, right?
Can you cross multiply and divide every problem, or is there sometimes where it just
Can you cross multiply and divide, like, we basically multiplied this times this,
correct, and then 7x?
7 times that, yes, but then you've added an additional step because now you're going to divide that 7 back again, which, yeah, so if you're happy doing it that way, you can. I thought I saw another hand. Yes? Because this is an equation, right? And I'm trying to get x by itself. What I'm doing is I'm multiplying this, whatever this was, which was 30 days, and I'm doing it on the right side and the left side, right? Don't get so caught up on the idea that this is days and that's gallons, because the days down here cancel the days up here. So like your units go away.
The 7 doesn't go to the 30 equally.
It does not. Yep. Yeah, that's okay though, because this times this is going to give you some number and you divide it by 7 and we get a decimal answer. It doesn't have to go in there. If we would have wanted to stick with weeks instead of converting to days, then you would have to tell me how many weeks are in 30 days. So you'd divide it by 7. You'd still get a decimal. Yes?
So I was thinking that maybe, you could have done, 24.7 divided by 7 because that's how much water you would lose in a day, and then you would multiply that by 30.
Same, and you get the same thing. Yep. All I'm trying to do is show you how we use proportions. And this is good. This, even though it might look a little bit weird, this is actually going to help when we do converting units. When we do things like converting feet per second into miles per hour. Because we use somewhat of a similar sort of proportion thing in canceling. And since it comes later, I may as well start showing you some of this now.
Yeah.
All right. Oh, did y'all want to hear my story? You're not going to hurt my feelings. You're not going to hurt my feelings. So I had to go to a high school graduation the other day. Had to is the key to that statement. Had to. And I don't know how many hundreds of kids there were, but there were a lot. And so I was there with my family, or my wife's family actually, and they were all like, well, I think his last name was Matthews. So they started calling the students up to walk the stage, starting in the A's and stuff. I'm like, dang, So they were like, how long is this going to take, and all this stuff. So I used a proportion. What I did was I looked at, they had a little handout that showed all the names, and there was like one page that had all these names on it, right? And I sat there and I timed it. So the person started and then they went through the whole page and it took like, I don't know how many minutes. It was like 12 minutes, right? So it was like 12 minutes per one page. And he was on like the 6th or 7th page, right? So all I did was said, well, this should be proportional to like 7 pages, whatever, and then it was going to be X minutes. And I was able to approximate, because of course they would take different times depending on how long people clapped. But so I told them it was going to be like, I forget what time it was, like, I told them it was like, it'll be like 7:12. He'll be called plus or minus 2 minutes, right? So around 7. I was within 1 minute. I was within 1 minute. And yeah, so I mean, that's a proportion, right? That's all that is.
So did you do that because you were bored, or because?
I did that because I'm bored and because I'm a math person. So I'm like, I can kill some. That gave me something to do. I'm like, okay, it's looking close. It's looking close. Yeah. And people would start cheering more. I'd be like, shut up, stop. We got to get to the next name. That's what math dorks do. All right, we are probably at a point where we can stop. Let me just see where we're going here. We still need applications of percentages, which is useful stuff because this is like tax and sales and things like that. So I would say for the homework for this one, you should be able to do all the homework You did everything